Hello, good morning. Hello,
Good
hello.
morning, sir.
Good morning. आवाज येतोय?
Yes,
Good
sir.
morning, sir. Yes, sir.
Okay. आणि slide दिसते का? Hello.
Yes, sir.
Yes, sir.
Yes, sir. It is visible.
Okay. So we'll start today. We have already started mixing of liquids, and we have seen the various type of the mixers which are used for the mixing of the semi-solid formulation as well as the solid formulation, right? So we today will see that the mixers can be used for the liquid formulation, right? So we have seen the different types of mixers, and the last time we have seen this figure, right? And this is for the mixing. This is for the mixing vessel, right? So we can use the different types of the mixing equipments or the mixing assembly, right? So this is the agitator. So can agitate the liquids, and the mixing of the liquid is possible. So at the side of both the side which having the baffles. So baffles which are mainly used, that is a small type of the knife which having the high speed, right? So the main purpose of this baffle is not producing any dead spot, not producing any dead spots in that the area, right? So in that area, so because this agitator is at that side at the center, but at the upper side or the below side, so is maybe producing the dead spot. So that's why these baffles are used, which having the highest speed of that baffle. So with that, the lower there's upper surface of that liquid or a below surface of that liquid will be participation in the mixing, and the 100% mixing is possible. So this agitator you can rotate with the motor, right? Then the feeding mechanism. So these continuous processes are there. You can addition of the liquid into that the vessel, and the mixing is possible. Then if you want to give the appropriate temperature for that vessel, right? So if you are giving the temperature, so that temperature should be cool in ordinary temperature. So that's why the cooling jacket is there. So it's a double vessel which are inside, there's a hollow vessel is there. So can passing that cool water, right? So cooling water, with that cooling water, so the temperature of that the mixture is the reduce it, right? And is make them normal. So this we have seen already this mixing vessels. Then we can use a different different impellers energy. So the particularly for mixing of the liquid or the semi-solid or solid formulation is required the highest energy for the mixing. We have seen the different shearing force is required for to the flow of the liquid from the one place to another liquid place, and the 100% mixing is should be possible. So energy should be required for that, right? So energy should be created by impellers, air jets, and the liquid jets. So these are the different example of that. Uh, is particularly for if you want to mixing of the liquid, is maybe emulsions are there, suspensions are there, mixtures are there, different syrups are there, right? So this type of the impellers, this type of the mixers can be used for to mixing of that particular liquid, right? So we'll see that the first, that is the impeller. So what is mean by impeller? So impeller are the mixing devices, right, which having the definite flow of the pattern of the during the liquid mixing, right? So we can moving that the impellers with the fast speed. So as per your viscosity of that liquid, we can adjust the speed of that the impeller, right? So liquids are mixed usually by the impellers, which are produce the shearing force, which are inducing necessary flow of pattern. So with this impellers, with that impellers is attached with the shaft and give the higher speed. So optimal speed should be provided. You can create the shearing force, and with that creation of the shearing force, right? So the flow pattern of the liquid is possible in the mixing. So these are the different types of the impellers are there. So impeller is broad category. In that impellers also can categorize with the classify this the propeller, turbine, and the paddle. These are the three impellers are there: the propeller, turbine, and paddle. So we'll see in brief about this. The propeller type of the mixer. So this is called as a propeller type of the mixer. So if you have seen the figure, so this is called as propeller. So these are angle blades. So these are blades which are attached to the shaft. So this is shaft, right? And this shaft is attached to the motor. So can rotate that the shaft with the blades, right? So these are the different blades will be attached. So this is called as a propeller type of the blades are there, right? So this is called as angle blades which are attached to the end of the shaft. So where the shaft is there, we can end of the shaft, we can just attach that the angle blades. So can rotated by the motor. This all these shaft is which are rotated by the motor. So number of the blades which are used is it is called as a 3-blade design, right? So maybe two blades are there, three blades are there, four blades are there, five blades are there. Depending upon the blade size, right, is create that the shearing force. Understand it. So this is a 3-blade type of the design is there. 3-blade type of the propeller. Propeller is quite small in size. The size is small as compared with the vessel. So the propeller is quite small as compared with the size of the vessel. So always be this proportion must be required. There is a diameter of the vessel and the propeller size. So the size of that propeller should be as 1:20. Means the maximum propeller, so propeller should be will be fixed at the center of the vessel, right? So can rotate that the that the blades, right? And after rotating the blades, the flow of the pattern of the liquid and mixing is possible. So the flow pattern should be appropriate, must be necessary. So that's why the size of the blade and the vessels of the vessels size, right, it should be appropriate. समजा की size your vessel size कमी है and your blade size असेल तर is a very difficult to rotate that rotation, right? समजा की 1:10 असेल तर काय होईल, the flow pattern can be changed, right? Or 1:10 means that so maximum the liquid should be passing from one place to other places, right, with the help of the flow pattern, right? So flow pattern is created by the shearing force with these blades. Understand it? So with this, we can compare the size and the produce efficient mixing should be necessary, right? So if you have changed the proportion of the vessel size as well as the blade size, it may change that the flow, the efficient flow or the non-efficient flow is also is possible, right? So this is about construction of that the propeller. Then working conditions, the material which are mixed to be the vessels and the propellers, right? So generally the propellers or the which are attached to the shaft at the bottom of the shaft, and this shaft is attached to the motor. Then this shaft which are inserted into the vessel, right, which containing the mixing, which contain the liquid or any material we want to that mix it, right? So angle blades of the propellers is the circulation of that liquid both the axial and radial direction. So both these angle blades which are rotated as such that which are producing the axial flow as well as a radial flow, right? These are the two flows we possible. So we'll see in next slide. So what is axial flow and radial flow? Axial flow and radial flow which are ensuring the good bulk transport from the low shearing force, right? So the maximum the transport of the material from the one place to another places, right? So 100 mixing is possible with the low shearing force. Understand it? So always this mixing should be done with the low shearing force, which gives the highest mixing mechanism. Understand it? So because if you use the highest shearing force, will be chances there is your blades to be cracked down, or maybe your vessel is cracked down, or any certain event is possible. That's why with the lowering with the low shearing force, which gives that efficient type of the mixing is possible. Then propeller may be installed at the number of ways. Is particularly as that centrally we can mount it that all the shaft, and the shaft is attached to that the different propellers, right? So different positions we can start at. So advantages of that propeller type of mixer is which are highest mixing capacity, right, which are highest mixing capacity. So the effectively for the liquid we have in the viscosity is 2 Pascal, right? So the viscosity, if the highest viscosity with that propellers cannot be used, right? So if the viscosity of that liquid is 2 Pascal, right, then we can use that the it is a propeller type of the mixers, right? So effectively as a gas and liquid dispersion. So this if you are mixing the mixer is the material which having that gas and liquid, both this combination of the gas and liquid, right? So that is a more advantages of that propeller type of mixers. You can 100% mixing is possible. Those who are mixing is gas and liquid dispersion. So particularly this type of the mixer can be used for to preparation of the multivitamin elixirs, elixirs, and can prepare the different disinfecting solutions. You can prepare the different types of the syrups also, with different types of solutions, different mixers, right? We can use that, but viscosities we can maintain that. So those viscosity of that liquid is 2 Pascal, right? So we can easily or efficiently mixing is possible. If I increase viscosity, it is not be sufficient efficiently mixing of that liquid. Right. This is disadvantage of the propeller is the propellers are not normally effective with the liquid is greater than the viscosity. Right. If the viscosity is more than 2, right, more than 2, it cannot be used at the propeller, and this is the disadvantages. So though if the liquid having the viscosity is maybe 5 Pascal, right, or maybe if having that glycerin or castor oil, as you know the glycerin is viscous in nature, or castor oil is also viscous in nature. If such type the mixing is there, right, so there is a propeller type of the mixer is cannot be used, right? So, but those having the low viscosity, that is the 2 Pascal viscosities, so it can be efficiently mixing that propeller type of mixers. Then centrally mounted is a vertical. So they generally can be, these propellers are centrally mounted at that vessel, and which are producing the vortex type of the mixing is possible. So propeller type of mixers is consist of the vessels and the propeller. The vessel is already there. So vessels and propellers. So propeller speed, having the highest speed of the propeller is speed of the propeller is 8,000 rpm. So within 1 minute we can rotate at the 8,000. So we can give that satisfactory flow of the pattern. So with that flow, the speed of rotation is very important, right? If the lowest speed of the pattern, the low speed of that propeller, so means that the flow of the pattern may be changed. If the highest speed is there, the flow of pattern may be changed. Understand it? So that's why you can satisfactory flow of the pattern must be necessary for highest mixing. That's why the speed of the rotation must be 8,000 rpm. Understand it? Then during the mixture of the liquid, so air can be entrapped into that formation, into the liquid. Sometimes if you are not close the vessels or close that vessels with the lid, right, or you cannot be use the cap for that vessels, right, it may chance that is a entrapment of the air into that liquid. Right, it is possible. Entrapment of the air into the possible air into that the liquid, and is a difficult to remove that that air from that the liquid. Right, so that's why you can avoiding that problem can changes the position of the propeller shaft. So if you have adjusted that propeller at the center, right, and if you have entered the more air into that liquid, then we can change the shaft position, right, from the left side or from the right side, or maybe that is angle side, we can use that, so can avoid a problem of entrapment of the air into that liquid, right? Then propeller mixers is not suitable for when considerable steering force is needed, right? If you require the highest steering force, right, so this type of the mixer is cannot be used, right? So if you have seen that the preparation of the emulsion, and the emulsion is containing the oil and water, we can mix this properly to form emulsion. Understand it? So for that mixing of the oil and water, right? So you require the highest setting force. Understand it? Is required high setting force, but the propeller type of the mixers is cannot be used for the emulsion, because emulsion is required the high setting force to prepare the emulsion. Understand it? So that's why this propeller is cannot be used for the emulsion. Then this type of the propeller shaft is there. So the propeller shaft, we can what is the position of the propeller shaft? So this is the first position is offset type of the center, from that away from the center at the right side. All right. So this adjusted that shaft as such that is not be attached to that vessel. Away from the vessel is very important, or the wall of the vessel is important. Understand it? Should not be stick up or not be touched to that wall. So adjusted propeller shaft is as such that at the right side as properly, or the left side, or the center. So this is position is away from the center, right? Then this flow pattern of that, so this a flow pattern is there. With this propeller, it's create the flow pattern as that after rotation of the various speed of the rotation of the propeller is create the this flow, right? Is material is going at the upward side, and again which are going at downward side. So this continuous mixing is possible with if you are keeping the shaft as the away from center. Then if you have mounted at the angle, so the angle side, you can just keep the shaft as angle side, so the flow pattern is as such that you can again which are going in the upward side, and again it is going downward side. It's same as to the circular type of the motion is possible, right? Then so can this vessel, we can attach that the propeller shaft at that side of the container, right? Is that side is the right side or the left side is depending upon this, and then can start your propeller, and this creation of that the flow pattern. So this some of this which are going at the upward side, some of this which are going at downward side, and again which are coming at that in the flow. That's not it. So if you have the pattern of the flow, if change by, you can shaft of that or the propeller can attach at the different position in the container, right? Then this is about the push-pull propeller, right? You can just at the center of that the container. So these are the two attachment of the propellers are there, the first attachment and the second attachment. So flow pattern is as such that can create that flow pattern from the left and the right side, and the left side is a different, right? So flow the liquid at that right side or left side, then again the second shaft, right? And this is a push pull type of propeller is there. Then is a use of the baffles. So baffles is also used. That's right. So these are the baffles are there. At the propellers we can just adjust it at the center, right? And which are create the start this rotation, right? And our start is rotation after rotation. The flow of the pattern is as that from the is the right side, and then again left side which are going in the upward side. Again we can fall down the below, and again which are coming into that process, right? So in that the baffles can be used for that. So we have seen the in first figure there is a baffles which attached at that wall of that vessel. So these are the left side and the right side. These are the baffles. So what are the liquid which are going at that side, right? Again we can this baffles is main role is that we can whatever the liquid which are at that side which are going that liquid should be passed to that the at the center, and whole liquid should be mixes properly, right? So these baffles can be used for that, right? So these are large size of the baffle is there, large size of the propeller is there. So this is a baffle is there. So at the left side we have seen this baffle. Is a baffles is a circular type, and these are the propeller, right? As which are situated at the center in the container. Understand it? And which are rotated at the different speed. All right. Propeller mixer is there. This is one of the example is a deep type mixer is marine propeller mixer, right? So this mixer, this shaft is attached to the motor, which a various speed of the motor is given. So these are the two propellers are there. The first is attached to that the end of that shaft, and which are attached at the center of that shaft, right? So then this is a one propeller mixer is propeller is there. You can attach at the three blades propellers are there which are attached to that the end of that shaft, right? This is one more. There is a clamp mounted portable mixer. So these are clamp mounted. So just you can, there's a handy type of the mixers are there. So if you have seen in a home, right, we can use a handy type of the mixer also. We can preparation of the juices or preparation of the any mixers, right, mixing, right. So this type of the mixers can be used properly. So this is called as clamp mounted the portable mixer, right. This is the three type of the three blades which are attached to that the one shaft, right, at the center of the shaft. So these are propeller mixers. Then is a pull push propeller type of the mixer is there. So pull push, there's a pull push, there's a two or more propeller which are opposite angle. So you can attach that. So this is a figure, if you have not seen that. So this is a figure, the first propellers, and this is a second propeller which are attached to that, both these propellers. But this propeller will be attached as such that which are create the opposite direction of that the flow pattern, right? Is the first shaft आहे, first propeller आहे, त्याचा फ्लो पॅटर्न वेगळा असेल आणि खालचा जो शाफ्ट आहे त्याचा फ्लो पॅटर्न वेगळा असेल, जेणेकरून जे मटेरियल आहे वेगवेगळे पॅटर्न असल्यामुळे, वेगवेगळा फ्लो असल्यामुळे, right, you can mixing both this, and each and every particle will be going in the process of the mixing, right? So it's opposite direction. So all this the two propellers which are attached in that two different angle, so you can create the different direction the flow, and all this the liquid should be flow as circulatory flow, and the mixing is possible. So bottom impeller which are pressed at that one impeller diameter, because so you can adjust it that the total impellers, the propellers in the at the center of that container or the vessel, so it should not be touch up to that bottom of containers as well as the side of the container. So it should be above that, the bottom should be necessary. Understand it? So it will not be disturbed at the wall. So okay, it should be create that zone of the highest turbulence property, turbulence flow. So highest turbulence flow it should be producing. So we can create that the turbulence flow, with that turbulence flow, highest mixing of the liquid is possible. All right. This next is called as a turbine of the mixer is also there. Turbine mixer. So you know that a different machine we can use a turbine type of the mixer is there. So it's particularly for the machine which are used for there is water, right? Water pump. You know the water pump. So water pump which are attached to this type of the turbine mixer paddles are there, right? So this turbine mixer is a construction of the turbine is consist of circular disc impeller. So these are totally circular, and in that the circular disc which are attached with a number of the short vertical blade is attached. So these are the different blades which are attached at that side of that the disc. So this circular side which are attached to the shaft, right, and that circular disc which are attached the different types of the small blades, right? So which are curvy in nature, which are very sharp in nature, right? So these are the blades are very straight in nature as well as curvy in nature. So different types of the blades which are attached to that the vertically at the side of that the disc, right? So these are one example of that the mixer. This is the second example of that the turbine mixer. So this is a curvy type of the this curve type of the blades are there, but this is a straight type of blades are there. Understand it? So different blades will be attached to the side of that disc, and the flow pattern should be possible. So blades is surrounded by inner and outer diffusing ring. So this also is called as a diffusion ring, right? So diffusion ring, in that diffusion ring we attach the different blades is a inner or outer, right? Inner side or outer side. So both these sides will attach with the blades, right? So diameter of that turbine ranges is from 30 to 50 of the diameter of the vessel, right? So temperature ranges means diameter of this turbine it should be 30 to 50% of the diameter of the vessel. Means if the capacity of that vessel is the maybe diameter is 100 of the diameter 100 centimeter, so you can use that turbine mixer is it should be 50 such that, right? So 30 to 35% of diameter of the vessel must be necessary for highest turbulent flow, which should be possible with circular disc impeller which should be attached. This working of this the similar manner with that is an impeller which are is rotated somewhat smaller speed than the impeller. The speed is for impeller have the speed is 8,000. Understand it? We have said, but in that this speed is this type of the turbine mixer with the speed is low, is a 50 to 200 rpm is the speed, right? So we can the flat blades, if I use the flat blades turbine which are producing the radial and tangential flow pattern, and the speed increases with the radial flow, right? So the speed of that rotation, the speed of the flow will be effective due to this the flare blades speed or the flat blade's speed. If the flat blade speed is should be have the lowest speed as a 50 to 200 rpm, which are producing that the radial and tangential flow, which are producing that the mixing. Then some of the simpler zone is a rapid current and high turbulence because the speed is high. So intense shear will be observed. With this, the disc type of the simpler type of the mixers, right? So it's having that high shearing force. The intense shearing force is possible, and there is no any zero duct is possible or the zero mixing is possible because the high turbulence flow is maybe created. So shear is produced by the turbine, right? And the diffuser ring. So we have seen the diffuser ring. So inner side and outer side of the disc will be attached that the different blades, right? And which attached to the diffuser ring. So diffuser ring is responsible for the flow pattern should be uniform. The shearing force, you can creating the shearing force of that, and with that shearing force will be applied uniformly to the every mixing, right? So you can losing the rotational spinning and the rotating. म्हणजे जास्त स्विलिंग मीन्स जास्त मिक्सिंग. म्हणजे मिक्सिंग करत असताना काही लिक्विड कंटेनरचे आपण बाहेर जाऊ शकताय किंवा आउटसाइड होऊ शकताय, राईट. दिस कॉल्ड एज स्विलिंग, राईट. द व्हर्टेक्सिंग मीन्स अप अँड डाऊन मोशन is a very high up and down motion. Swelling means there is a left and right motion, right? So the proper rotation, the flow must be necessary for with that so can increasing the shearing force. It may passes with perforation during this. So that's why diffusion ring should be used for with that the shearing force, right? It will not be producing any rotational spinning and vorticing. It not be high is up and down motion of that fluid, as well as the left and right direction, the flow of the pattern should be optimum, right? So that's why you can reducing that with the help of the diffusion ring. So advantages of the turbine mixer: turbine is give the greater shearing force than propeller. Is one of the advantages, right? So turbine gives greater shearing force than propellers with the speed low. With the low speed is give the highest shearing force, right? Therefore, this the turbine mixers is used for the emulsification. So we have seen the propeller type the mixers cannot be used for the emulsion. You can use for the mixers, you can use for that suspension, but it is used for the solutions, right? But it cannot be used for the emulsion because they will not be producing that that type of the shearing force. Because the shearing force with that the turbine is given the greater shearing force, and which we can producing that the emulsification or the preparation of the emulsions is possible with the turbine mixer. So effective with the highest viscous solution. So the paddle type of the mixers, the propeller type mixers, only the if those have the low viscosity of preparations is not more than 2 Pascal, but in a propeller type of the mixers, turbine type of the mixers, we can the viscosity of the liquid is 7 Pascal, right? Then it also is possible for the highest mixing, right? So low viscous material which are large volume turbine is create a strong current just fade throughout the destroying the stagnant bucket. So what will happen? So if I use the low viscous material for that turbine mixer, right? And if I use the turbine mixer for the low viscous material, is create the strong current, and with that current, right, it may chances is some of these baffles will be destroyed, or maybe walls is destroyed. Some of the packets inside the vessel is also can be destroyed, because the proper viscous material can be used to the mixing with the help of the turbine mixer, right? So you can handle the slurry with the 60% of solids. So those mixture, those are preparations which should be containing the 60% of solids into that liquid. Then it can be will be possible with this turbine mixer. So turbine is suitable for the liquid which are large volume, which as well as the highest viscosity of that, right? जास्त जरी volume असेल आणि viscous जरी material असेल, you can use that turbine mixer is possible, but we can use the different baffles. So this is one more type of the radial flow. So what is called as radial flow? So this is one type of the turbine mixer. We can create this pressure, and with that creating the pressure force, right, it will be the flow of the pattern is the radial flow. So this the flow, this disc is which are rotated at the circular, and with that circular rotation, which are a flow is created with the radial flow. Understand it? So this type of the flow, this type of the turbine, right, which are create the axial flow of the turbine, right? So you can rotate it his own axis, right? Rotate his own axis, and with that rotated axis, which are producing the axial flow of that the turbine. So this is a turbine mixer. The circular disc is that. So these are the one more example. Turbine mixer is we can use for preparation of the syrups, or maybe liquid paraffin, or maybe glycerin. So those are high viscous material we can use to prepare the mixer with the help of the turbine mixer. So this is a turbine mixer. This is one example of that. Then, so this is also this type of the turbine mixer is also there, which are spiral blades which are attached in the inside, right? So you can just passing the liquid into that viscous liquid into that, and after passing you can start that. The blades is a spiral blade. It is called as spiral type of the blade we can use, right? And so you can producing that the mixer. And this is a flow pattern will be agitated at the various speed. So this is called as a flow pattern. So if you have seen, this is a A is a flow pattern. A is a axial flow pattern, right? So if you see the first figure is axial flow. So what is meant by axial flow? Axial flow. So this road, this shaft is which are rotated is axis, own axis, which axis, and we can create the flow. So in that flow, we can create that flow from the so this material which are going in the upward side, and again which are going the downward side, right? So whatever the going at the below side, again we can go in the upward side, and these are the both this possible, right? So this flow is called as a axial flow, right? म्हणजे इकडून लेफ्ट साइडला पण जाईल आणि लेफ्ट साइडला पण जाऊ शकते, ठीक आहे. Then next is that so you can baffle vessel. We require the baffle. So these all is the flow pattern is require the baffles. There is a both the side, there's the right side, the left side. We can use the baffles. So not be producing any dead zone, right? Then B flow, it is called as a radial flow pattern, right? So these are radial flow. These are the different paddle. These are paddle can be used. And paddle is attached to that center as a end of that shaft, and the shaft is attached with the motor, right? So this flow pattern is there. So some of the material which are going upward side, some of this material which are going downward side, and again which are coming into that mixer at the center. It's both this for left side, right? Both this for left side, both this for right side. Somebody is going upward side, somebody is going downward side. So, but in this axial flow, which are going at the downward side, right? And then again we can go on upward side, right? So both is possible. So then, so these are about the radial flow pattern which are baffle vessel. The baffle is also required. So then C is for tangential flow pattern is there. So unbaffled vessel, this baffle is not there, right? So in this case, the baffle is not there. So this tangential flow is there. So this is a shaft is attached with the, this is the paddle. This is a different paddles can be attached to the shaft. Okay, and here the shaft we can rotate it is on axis, and with that rotation is a create that the flow, right? And this flow is called as a tangential flow. This called as tangential. The flow this rotation झाल्यामुळे काय होईल, the flow pattern हा tangential flow type होईल. म्हणजे this same as to that vertical triangle is the same as to flow is triangle, or it is called as a tangential flow. Okay, so this is about the flow pattern. Then this is a different design of the paddle mixer. This is also one of the designing. Is also one of the designing. Okay. Next, the paddle mixer. The paddle mixer are agitator type of the mixer, which are flat blades attached to the vertical shaft. Is normally operated as that low speed. The speed is very low, is 100 RPM, right? Then blades have the largest surface area, which are we can use very effectively, right? So blade size should be appropriate. So can with the rotation which are create the force, and with that effectively mixing is possible, because that blade should be required the highest surface area, right? Large surface area, so can the flow pattern should be appropriate, and mixing is possible. So primarily that is a parallel mixer which are producing the tangential flow, somehow the radial flow, somehow, and is no axial flow is possible, right? For this paddle, we have seen this last figure, last slide. Then next is a liquid mixers. There's a shaker mixer or a propeller mixer, turbine mixer, paddle mixer. There are different types of the paddle mixer we can use. Simple paddle mixer or planetary motion mixer or cat mixer or stationary paddle mixer. These are the different types of paddle mixer can be used. Right. Simple mixer have the different attach the different paddles to that the shaft and can rotate it at various speed. It is used for mainly for the solutions, right? That can be used. But planetary motion mixers, which are used for the small paddle rotating its own axis and which are travel into the circular path, right, around the vessel. So it's the same as to planetary tram. We can rotate that that paddle at that various circular motion. It can be rotated, and after circular rotation of the rotated, which are producing the planetary type of the mixing or round of the mixing vessel. It is used for the more viscous liquid we have seen. Then gas type of the mixer is also there. The simple paddle is a very large in the diameter. So diameter is larger, but it is not bit larger than the vessel, right? Is a compared with the planetary mixers. Then stationary paddle mixer, it is used for the mixing of the solid with the viscous liquid. Or we can use other semi-solid also. So stigma plate mixer can improve this form of that stationary paddle. Then uses of the paddle are mainly used to manufacture different types of the formulations. If you want to prepare suspension, maybe antacid suspension or different types of suspensions, we can prepare with we can use that paddle mixer. Then you can use a different types of the mixer. Maybe we have seen the different mixers, maybe diffusible and indivisible, right? So those maybe diffusible mixer or individual mixer, individual mixer also can be prepared with this the paddle type of mixer. It's mainly contain the agar or a pectin or maybe antidiarrheal mixture also can be prepared with. This is an example of that. Bismuth kaolin mixture is mainly used for the antidiarrheal preparations, right? And that can be used this paddle. Then advantages of that paddle is possible because the low speed, so highest vertex action and the highest efficient mixing is possible with low speed. It is not more than 100 speed is required. Then a disadvantage of the paddle is the mixing of the suspension is poor, therefore baffle tank is used. Sometimes if you want to prepare that suspension, at that times the baffle is necessary. So at the left side of the container or the right side of the containers, different baffles will be attached, and with that baffle, right, they create some shearing force with the high speed of the baffle, creating shearing force, and the mixing is possible. So this is the then one of this series called as a air jet type of the mixer is there. So air jet can passing the inert gas jet effectively used for the mixing purpose of liquid, right? So air jet is means air is passing to that the liquid, with that air is that create the flow, right? We see in a figure of this, right? Then which having that low viscosity of material, having the low viscosity of material, sensitivity of the material can be used. No foaming action because the air injet may be chances the foam, all right? So those material having the low viscosities, those having the non-foaming, those are the non-reacting gases employed, those having the non-volatile nature. So such preparations we can use for highest mixing. If you use that air jet type of the mixer. So this is a air jet type of the mixer is there. So this principle, main principle is considered there is a compressed air jet. So this is a compressed air. So if you have seen this containers which are containing the different material which are low viscous material, and in that low viscous material we can passing that the compressed air. So this is the below side, at the bottom side of the containers or the vessel, and passing that air. So this air is there, right? So with that air, what will happen? So it can create the flow, right? So the material which are passing to this from the outside, from the upward side, and again which are going the downward side. So upward side and going the downward side is a many time, right? So and this mixing is possible with. So that's why it is called as a air jet. So air jet means compressed air or inert air which are passing with the highest pressure at the tank of the bottom of the tank. Right. This is called as a fluid jet is also there. So with the fluid jet means that the pumping operation is used to transfer the liquid to the mixing tank. Right. So if you want to transfer the liquid from one tank to the another tank, you can use that the pumps. Right. Use that the pumps. So the pumps can be used to transfer the liquid from the one tank to the another tank. So main mechanism of this fluid jet is there. So the fluid is pumped through the nozzle, right? So the passing that the liquid through the pumps, right, from one tank to the another tanker. So in between which are attached with the different orifice nozzle. Nozzle is attached with that. So with that nozzle, then passing the liquid through that nozzle, right, and it's creating that the force, and with creating the force, so the mixing is possible. So fluid is pumped through that nozzle, which are permit the good permeation circulation of that the material in the tank. Understand it? So fluid jet is operation is very like the propeller, right? But which are producing the turbulent flow in the direction of that axis, right? So simply there is a pumping can be used, right? In that pumps can be used and transfer the liquid to the one container to another container, and with this in between we can attach with a different orifice or the nozzle, right? And through that nozzle we can passing the liquid, right? And that is called as a fluid jet. So these are different types, tubes and types of the mixers are there. So in this, the material flow through the tubes or the pipes. Right, we can use the different pipes through passing the liquid to the one place to the another places. Right, or we can bag the liquid also. Right. Then in that the bit in between the tubes or the pipes, you can use the different baffles or the rod. Right, you can use the different baffles and the rods in between the pipes. Right. So you can place in the between the pipes and so can enhancing the mixing mechanism. So can the mixing is should be the highest and mixing is possible with this the baffle. So in between you can attach with that. So these are the mixing is such system which are occurs to the mass transport in the direction of the normal to the primary flow. So means we can so this type of the mixing can use fluid jet type of the mixers. We can passing the liquid from the one container to another container or one place to the other places, and in between which are attached with the different baffles on the rod, and so can highest mixing is possible, right? So this is about the mixing. Okay. Hello. Everybody is there? Hello.
Yes, sir.
Okay.
Yes,
Yes,
sir.
sir.
So we have completed
Sir.
the chapter. There is a mixer, mixing. Okay. Any problem in that mixing? Hello.
No, sir.
No, sir.
Okay. So we stop here today. Okay. You can leave.
Okay, sir.
You can leave.
Thank you, sir.
Thank you, sir.